So oftentimes when people go in for getting the blood vessels and stuff checked out, they have a very hard time finding the right blood vessels. Um, so multiple jabs, which can be painful, or they find ones that's deeper down, which is more painful. You could also look at this as helping maybe vaccines or administer medicine to put in areas of the body is better. Sometimes you want it close to blood vessels. Sometimes you want it close to fat, because fat can help absorption. Sometimes you want it close to meat or muscle. Sometimes you want it far away from bones. So a simple imaging sensor that could locate all the stuff could be very useful. Now we have some ones that already exist. They're not widely used. They use infrared light and near infrared light and red light. These types of lights can image it, but they can't make a 3D scan, and they can't image every type. But I think if you had more types of lights in it, you could figure out how to do it. And one way would be a little bit of you radiate a little bit with microwaves. Not enough to really cook anything, almost a measurable amount for most things. What these microwave lights can do, and microwaves are more absorption independent than other colors, is heat up the water. Now microwaves heat up water and make them emit stuff, because what they do is water is a polar molecule, so the oxygen attracts electrons more. And remember, water looks kind of like a teddy bear with two H's near the O, and the O is a lot bigger. And it has a negative charge, and hydrogen loses electrons and has a slight positive charge. The microwave is electromagnetic radiation, and it kind of is the right size to turn this molecule around, because it goes up and down, and the molecule kind of finds this and spins. Now, if I can use other technology to image it, such as infrared and microwaves, I can see this glowing up much more by putting a short burst to heat up and measuring how the stuff that's hot moves. And that can give me an idea about what is dynamic flowing blood vessels and what's just muscle and stuff. I can get an idea if I heat up different sections, how stuff is moving quickly, and you can flash these lights really fast. You can also get a measurement of depth by having it focus differently at different depths to build up that image, or look at how, or pinpoint it if you have a lot of little lights. So you get all this data. Also, different types of wavelengths of light are absorbed differently by different tissues. The famous one is pulse oximeter, pulse, then LXIMETER, which is a very cheap device that can measure absorption of a bunch of different, measures blood oxygen levels with just two light waves. And with this thing, we can also measure hydration level, pulsing of blood by seeing how the absorption changes with time, and we can get a little bit of the heart problems, not a lot, but a little bit if there's severe, the pulsing is weird. We can get the idea of muscle versus fat, because they have different absorption, versus bone. Not very deep, not very double pixel, but very local surface. So a ton of data. If we add an ultrasound to it, we could get even more, because you can measure the ultrasound, because we all know how an ultrasound is. The problem with the ultrasound normally is that you need to put a liquid to help it with the contact with the skin, because the liquid provides a more smooth transition from the emitter to your skin to inside your body. Air does not provide a smooth transition, because it's different density, so sound scatters like an echo when it hits your body. But the echo is not a big deal with ultrasound, because what happens is with this idea, because the microwaves and waves and other waves that are radiated will detect the scattering of the light, that will detect the ultrasound, how it's moving within the body, not outside where it gets the interference. And it could potentially make a more in-depth measurement. Another thing that this thing could do, potentially, is you could use it also as a therapeutic thing to locally heat up areas, like a hot pad. Another use, you wouldn't have to touch the person to image it, even though closer might give you better images. And yeah, that's a ton of uses for it. And how would I build this? Well, we already have LEDs for all these things, and we have a variety of them. And LEDs you can make quite small, so it'll just be an LED panel of a bunch of them over here to illuminate different patterns. Then you could have a liquid crystal display, LCD, and what that could do is polarize the light. And the polarizing the light means that light, instead of vibrating in all directions, vibrates only one direction. You can think about it as if you imagine it in a plane, it could vibrate along the plane, perpendicular to a plane, or any other combination, up and down, side to side. There's also circular polarized, which is vibrating in and out, but you can have left or right circularized, depending on what phase it is. The thing about polarized light is different molecules do absorb differently polarized light differently, but also that if you quickly switch the polarization, you can emit more energy, make a molecule emit more energy than normal, and make a stronger pulse than normal. And that is done by first it vibrates in one way, loses that energy quickly, but then it vibrates in a different way and loses that energy quickly, or different pathways interfere in different ways, like perpendiculars might interfere or something. It's really complicated, but it can happen. So something vibrating this way might lose its energy really quickly, but it can have half energy go this way and half there suddenly, or it can vibrate here, then suddenly get knocked to vibrate here and just interfere with it. It's weird. Other things it could do with polarized light is that some molecules absorb unpolarized light better, some absorb polarized light. So you can have that. Some molecules, when they absorb polarized light, you can tell how big it is because it tumbles and emits. And because it's tumbling, when something tumbles, if it has one dimension that's a lot bigger than the other dimension, it changes more how it absorbs polarized light and emits different light, because it has more area to absorb light along a certain direction. And if that direction happens to line up with the polarized light, it can do it better. So that can give you some more chemical information. It can give you chemical information about healing of scar tissue and stuff, plastic implants, because some of those stuff line up. It can also give you the circular polarized light, which can give you a lot of information actually about the sizes of molecules in blood, which will just give you a rough overall size, but it might be useful data if there's clotting or something, or selling bigger molecules. There's ways you can make this even more advanced. For example, malaria produces a lot of molecules of polarized light, but they're usually not very well lined up, so hard to detect. But with the magnets, you can actually line these up, preferably because they contain iron. A lot of iron compounds that are slightly magnetic. And if you move a magnet, they have papers on this, the polarization of the light follows the magnet moving, and if you take this repeated cycle, you can detect malaria. So you could build this into malaria. You could make this actually make an ultrasound device itself, where the sensor is directly, where the pulse is produced by skin by pulsing light that suddenly vibrates molecules and stops vibrating them, vibrates them and stops them, making pulses throughout the skin. And that could give you more control than traditional ultrasound over it. Not as powerful pulses, but pulses could be made throughout the entire skin. And they could be made with more, how would I say it, accuracy and special shapes that can give you more data instead of just a broadband. So potentially more data from that one. And then with the machine learning algorithm, you could change up onto the fly to different types of pulses. Well, thank you for listening. Please like and subscribe. It really helps the channel out. And also, always, if you have any comments, ideas, or suggestions, please leave them in the comments section below. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard. With your help, I think I can do it. Also, if you have any ideas for future videos, comments, or suggestions, please leave them in the comment section below. Thank you very much again. Goodbye.